Welcome to AI Frontiers. Today we explore a critical question. Can AI truly understand what it sees? With 59 computer vision papers released on October 30th, 2025, we're examining how today's AI generates stunningly realistic videos, yet fails basic causal reasoning questions. These papers revealed a next frontier, moving from static images to dynamic world understanding and true comprehension. Today's journey through computer vision maps the frontiers of visual intelligence. We'll provide a comprehensive field overview, showing the transition from recognition to comprehension, identify 5 dominant research themes emerging today, highlight key breakthroughs in multimodal understanding, examine 3 seminal papers defining the field's direction, and discuss future challenges and ethical considerations. Computer vision continues its remarkable evolution from static images to dynamic world models. The field has progressed from object recognition and classification in the past to foundation models and transformers in the present, and now moves toward integrated reasoning and comprehension for the future. This technology drives critical applications including self-driving cars and medical diagnosis, building AI that can meaningfully interact with the real world. Theme 1 focuses on multimodal and language-guided vision, closing the loop between seeing and describing. This involves AI systems that can discuss and reason about pixels, with researchers like Fan et al. Working on better text-visual feature alignment. New benchmarks are being created for complex text-to-video generation, enabling AI to follow detailed visual instructions and creating more reliable and interpretable systems. Theme 2 explores 3-dimensional and 4-dimensional world modeling, escaping a flatland of 2-dimensional images. Systems like SEE4D can transform casual videos into dynamic virtual reality models. 3-dimensional Gaussian splatting provides fast scene representation, while OmniX enables graphics-ready 3-dimensional scene generation. This includes understanding light changes and temporal dynamics, moving from pretty facades to physically accurate worlds. Theme 3 addresses efficiency and real-world reliability, turning brilliant prototypes into trustworthy tools. PTDTR enables tiny object detection in drone footage, while ATPT provides on-the-fly adaptation to new data. Test-time adaptation allows learning in dynamic environments, handling messy and unpredictable real-world conditions to ensure models work reliably when it matters most. A key finding reveals the reasoning gap, where Guo et al. Demonstrate fundamental limitations in current systems. Video models fail at long-horizon causal reasoning while succeeding only with short-term local physics. They cannot simulate complex cause-effect chains and struggle with strict geometric rules. This shows that generation capability does not equal true understanding of the world. Another key finding involves unified world models, where EMU 0.5 points to a new paradigm. Cui et al. Demonstrate native multimodal learning that predicts the next step in unified visual language sequences. This enables long-horizon generation mixing text and images, shows glimmers of open-world embodied manipulation, and creates single models, learning grounded world understanding. The technical deep dive examines 3 powerful methods driving today's breakthroughs. Diffusion models scoped reality from noise, transformers understand long-range context, and test-time adaptation enables learning during deployment. Each method has unique strengths and limitations, and their combination creates robust, capable systems for advanced computer vision applications. The first seminal paper provides a reality check. Guo et al. Systematically test video model reasoning capabilities using the MME-COF benchmark across 12 logic dimensions. While successful in local tasks, models fail in causal chains and cannot simulate Rube Goldberg machines. This work serves as a vital corrective to generative AI hype. The second paper represents a 3-dimensional creation breakthrough. Huang et al.'s OmniX solves bottlenecks in 3-dimensional content creation, using a lightweight adapter for 2-dimensional foundation models. This unified panoramic generation and perception system outputs scenes usable in game engines and simulations, dramatically reducing 3-dimensional creation cost and time. The third paper demonstrates a paradigm shift in learning. Qi et al.'s EMU 0.5 uses a single model predicting next visual language tokens trained on 10 trillion video text tokens. Discrete diffusion adaptation provides 20 times speedup, enabling emergent, long-horizon generation capabilities and pointing toward general capable AI agents. Future directions point toward true reasoning and causal understanding as the path ahead. Efficiency improvements through faster sampling and model distillation will be crucial. Active and embodied AI will learn through interaction, while ethical auditing addresses bias and fairness concerns. Safeguarding against misuse of powerful technology remains a critical priority. This presentation was created through AI synthesis and review processes. Content synthesis utilized the GPT DeepSeek-Chat model with text-to-speech generation via Deepgram. Visual concept design employed StableDiffusion, and human expert review ensured accuracy and clarity. Potential oversights are acknowledged with references provided for verification. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.